Today we're going to look at angles on a transversal. A transversal is any line that intersects at least two other lines. That is, it crosses those lines. So it crosses two or more other lines. Lines are parallel if they do not intersect. That means they'll never meet. They're moving along in the same direction. They are marked with the same number of arrows. So these pairs of lines, this pair of lines here, are parallel, and they will never intersect. Even if we kept drawing them on and on and on, they would never intersect. These two lines here are parallel as well, but they're not parallel with these ones. They've got a different number of arrows. So these two here are parallel, and these two here are parallel. If two parallel lines are intersected by a transversal, then the corresponding angles are equal. Now the corresponding angles are the same angles in the same positions on the transversal, and on the transversal where it intersects the parallel lines. So if we see this and we're being asked to solve a problem using angles and determining corresponding angles, we can use this key symbol, this coded reason, to show that that's the coded reason that we're using, that corresponding angles are equal. So not only are these two angles equal here, but these two angles are corresponding as well, and they will be equal. These two angles here are corresponding, and they will be equal. And these two angles here as well will be corresponding and will be equal. Alternate angles are equal as well. So we can use this coded reason here when we're looking at this. So alternate angles are the angles that are inside, both inside inside in between the two parallel lines, but also opposite each other. So not only are these two angles here equal, but also these two angles here are alternate angles as well, and they will be equal. Co-interior angles sum to 180 degrees. That is, the two angles that are inside, co-interior, they're both inside on exactly the same side as both the transversal and the parallel lines. They will add to 180 degrees. And this is the coded symbol, the coded reason that we can use here to demonstrate that and to show that we're using that when we're trying to solve a problem. So not only are these two angles co-interior, but these two angles here are also co-interior, and they will sum to 180 degrees as well. Let's have a look at an example here. We're being asked to find the values of pronumerals in the diagrams below. So here we've got two parallel lines intersected by a transversal, and here what we actually have is we've got two pairs of parallel lines that intersect at four corners, making a parallelogram. So for our first problem here, we can see, to determine A, these two angles here, they are corresponding. They're in the same position. They're in the same position on the transversal in relation to the parallel lines. So they must be the same. So A here is going to be 120. So that angle here will be 120 degrees. And we've given the coded reason there, our corresponding angles coded reason. B here is an alternate angle to A. So it's on the interior, the inside of the parallel lines here, but it is on the opposite side of the transversal. So it's an alternate angle. So it's going to be the same as A. So B is going to be 120, and we can give the alternate angle coded reason. You can see here as well that B is vertically opposite from the 120 degrees. So we can use the vertically opposite reason as well. They're both just as valid. And lastly, to find C, C is co-interior with B. So these are both inside the transversal and inside the parallel lines here, C and B. So they must sum to 180 degrees. So C plus B must be 180 degrees. So that means that C plus B, which we know is 120. C plus 120 must be 180 degrees, and that means that C must be 60. So we can use the co-interior angles coded reason there. We can also see that both A and C are on a straight angle here. They must be supplementary, so they must add to 180 degrees. So we can use the supplementary coded reason as well, and it would be just as valid. For our second example here, if we're looking at A and 72 degrees and their relationship to each other, if we're thinking about these two parallel lines here, this line here is acting as the transversal, cutting those two parallel lines. So because it's cutting those two parallel lines, we can see they're co-interior. They're both on the transversal, on the same side of the transversal, in between the two parallel lines. So A plus 72 must be 180. So that means that we can use the co-interior angles coded reason, because they're both on the they're both co-interior to the transversal there. So because A plus 72 must be 180, that in order to make that statement true, A must be 108 degrees. So that's 108 degrees there. If we have a look at these two parallel lines here, our line here is acting as the transversal, cutting through those two and intersecting these two parallel lines. So B and 72 are also co-interior. They're also co-interior, so that means that B plus 72 must also equal 180 degrees. So B must also be 108 in order to make that true. So we're using co-interior angles, a coded reason there. So we can see as well that we get an interesting outcome, that if we've got a parallelogram, the opposite angles here are equal.